Arcs and chords. Arc and chord relationship. In a circle, if two minor arcs are congruent, then their corresponding chords are also congruent. So in this circle, if arc AB is congruent to arc CD, then AB, the chord, is congruent to CD, the chord. Inscribed. A polygon can be inscribed in a circle when all of its vertices are on the circle. A square is inscribed in a circle. If the vertices are connected to the opposite vertices and angles are formed, what is the measure of angle AEB? Inscribed example. All the central angles in a regular polygon are congruent. So if we have 4 central angles in a square, then we are dividing the circle into 4 congruent parts. Therefore, we would have 360 degrees, which is the whole circle, divided by 4 parts, and that would equal 90 degrees. So 90 degrees is the measure of angle AEB. So if we had a regular octagon, it would break up into 8 congruent parts, because an octagon has 8 sides. So we would have something like 360 degrees divided by 8 equals 45. So each central angle would be 45 degrees. Circumscribed. A circle circumscribes a polygon because it contains all the vertices of the polygon. A circle is circumscribed about a regular pentagon. What is the measure of the arc between each pair of vertices? All the central angles in a regular polygon are congruent. So in a pentagon, 5 central angles are congruent, which means we have 5 congruent corresponding arcs. Therefore, we'll have 360 degrees divided by 5, because we have 5 arcs, equals 72 degrees. So each arc is 72 degrees. Diameter and chord relationship. If a diameter or radius is perpendicular to a chord, it bisects the chord and the corresponding arc into 2 equal pieces. So in this picture we have diameter AB is perpendicular to chord CD. Therefore, the chord CD is bisected as well as arc CD. Example 1. We have circle O has a radius of 13 inches long. Chord CD is 24 inches. So if the measure of arc CD is 134, find the measure of arc CB. Since OB bisects CD, because they're perpendicular, the measure of arc CB is 1/2 of the measure of arc CD, because we're bisecting them into 2 congruent parts. Then we're going to plug in what we're given. So the measure of arc CB equals 1/2 the measure of arc CD, because it's being bisected. So we have 1/2 of 134, which equals 67. So the measure of arc CB equals 67. We're going to find OX. First, we're going to draw radius OC. This creates a right triangle. We know the radius is 13 from the problem, so we have to find CX. Since we know chord CD is 24 from the problem, and the radius OB bisects it, then CX must equal half of 24, which is 12. Now we can use the Pythagorean theorem to solve for OX. So we have a squared plus b squared equals c squared. So we plug in what we know. We know one of the legs and we know the hypotenuse, which is OC. So we have 12 squared plus b squared equals 13 squared. B squared equals 25. And once we square root that, we get b equals 5. Therefore, OX equals 5. Chords equidistant from the center. Two chords in a circle are congruent if and only if they are the same distance from the center. So chords AC and DF are equidistant from the center. If the radius is 26, find AC and DE. AC and DF are equidistant so that they are congruent. We draw the radii AG and GF to form right triangles. Now we can use the Pythagorean theorem to find AB. So AB squared plus BG squared equals AG squared. AB squared plus 10 squared equals 26 squared. AB squared equals 576, and AB equals 24. Since the radius is bisecting the chord, we know that AC is going to be 2 of what we found AB to be, so equals 2 times 24 equals 48. So AC is going to be 48. Example 3 continued. Now since we know that DF equals AC, and we know that both chords are being bisected, AB would equal CB, which would also equal FE equals DE, and they all equal 24.